Hello again, this is Mr. Howard. We're going to be looking at a screencast for the Elements of Life unit, looking at atomic structure and then talking about some Bohr models. So let's get started here. What you need to have completed before watching this video would be the Building Blocks of Matter video, and there's a handout in the packet that you need to fill out. You should also have completed the ChemThink activity, filling out the worksheet packet, and then do the tutorial that's part of the ChemThink as an AFL quiz over that content information. If you do that, it's going to help you understand the information we're going to deliver here today. We're going to be looking at atomic structure. Now, what we want you to do as young scientists is begin to look at the periodic table and organize and get a sense of what some of that information or those numbers associated with a symbol represent. And you can see on the right hand side, and I'm going to show with the mouse here, here's what all the different symbols represent. Okay, so that's the element symbol and then mass number and atomic number. So this is all the information that we can come up with, and this is helpful for filling out some of the worksheets that we have so you get familiar with the different symbols and numbers associated with elements, and then as we begin working towards reactions and things like stoichiometry, we're going to come back and sort of use some of this information to help us create compounds and things like that. Let's move on. So, through the work of Dalton, Thomas, Rutherford, and then finally Bohr, we come up with a general representation of an atom. We now currently think of the electrons moving in a cloud, but Bohr, following again the work of Dalton, Thomson, and Rutherford, began to look and picture an atom having different energy levels that electrons would move around in. Okay, so you can see hydrogen here with one electron, just has one little ring. When you move over this lithium, you can see that you have an inner ring and then you have an outer ring. So we're looking at 3 electrons. Something that you should be able to pick up on is that lithium, and then you go over to sodium, that first inner ring seems to only have a maximum of 2 electrons. And we're going to start looking at this idea as we move through building Bohr models, because we have some practice worksheets for you. And this just sort of helps you determine how many valence electrons that an atom has and how that might help you determine what type of molecule to build, or how you build a particular molecule, rather. So, looking at the Bohr model. I'm going to read this. It says, Niels Bohr said electrons are arranged in shells around the nucleus. Okay, so here's your nucleus, and the yellow around here are your electrons. Electrons shells hold a limited number of electrons. We are going to primarily be working with this idea of the octet rule, which is the gain or loss of electrons to attain an electron configuration of the nearest noble gas. I'll say that again. The octet rule is the gaining or losing of electrons to attain an electron configuration of the nearest noble gas. Okay, this is a good question to ask your teacher in class if it doesn't make sense. What electrons or what atoms are trying to do is become like the nearest noble gas. And again, if you're not quite sure what a noble gas is, go back to some of that review information, or that's a good question to ask your teacher. But very short answer to noble gases, I apologize about that, folks. The noble gas is essentially a set of atoms that are stabilized, that they're not seeking to gain or lose electrons, and they rarely occur in reactions. We're not going to see them in many reactions throughout the rest of the year. So let's move on here. Step 1 in drawing a Bohr model is determine the number of protons. The atomic number is the number of protons in an element. And you can go back to that first sheet that showed you the atomic chart that laid out all the characteristics of an atom found on the periodic table. So we have an example here of sodium. We have a 23 at the top here, and we have an 11. And this 11 is going to represent the protons. One rule of thumb is that this might look different on the periodic tables that we hand out to you. What you need to understand is the smallest number associated with this symbol is always going to be associated with the protons. Okay, the larger number is going to be associated with the atomic mass, and that mass number here is protons plus neutrons. Okay, so we draw the number of protons in the middle of the atom like this. So we have 11 protons, so we say 11 P for protons, and a positive sign indicating that protons have a positive charge. In the atom, the number of neutrons equals the mass number minus the atomic number. So 23 minus 11 equals 12 neutrons. So now we have 12N with a 0, meaning neutrons are neutral charged. So every Bohr model, and we're going to only have you do the first 20, you need to write this out so you understand the number of protons and the number of neutrons that that atom has. We follow it by step 3. We're looking at neutral atoms at the moment, and a neutral atom is any atom that you find on the periodic table. It has a complete number of protons and electrons, and it's completely balanced in the sense of number of protons is going to equal your number of electrons. So in this case, we're saying you have 11 protons, you also have 11 electrons. It's a balanced or neutral atom, anything on the periodic table. When we start getting into bonding, we're going to get to ions, and that's going to be either more electrons or less electrons, which will cause that atom to be either a cation or an anion. Moving on. Steps to drawing a Bohr model, fill in the energy levels. So, energy shells hold a limited number. We're going to work off this octet rule, which I didn't mention earlier is 8 electrons. So the first shell always holds 2. Okay? So the only element that doesn't have 2 electrons in its first shell is hydrogen. All other atoms will start with 2 electrons in its first energy level. Then every other shell that we're going to deal with in our class is going to have a maximum of 8 electrons. So we're only focusing on about the first 20 atoms that you're responsible for doing Bohr models with. And the maximum number that those shells can hold will be 8 electrons following the octet rule. We have some other descriptions here to tell you the number of electrons that are filling in each shell. So what we can just figure out from this diagram here is that sodium has 3 energy levels, and we should be able to find that sodium is in the 3rd period on the periodic table, and that's the horizontal rows on the periodic table that you see in class. So we start with the first energy level and we get 2 electrons. Then we build out to the second energy level, and you can see that we have 8 electrons that fill that. And then we go to the next energy level, or 3rd energy level, or in our case, the outermost energy level, and we have 1 left over. So if you actually count the number of atoms, you have 11. If you count the number of electrons, you'll come up with 11. So you have 1, 2 here, plus the 8, so that would be 10 for the first 2 shells, plus that additional 1 on the 3rd energy level, which is 11 total of electrons. So I would go back through this again, maybe a little bit more slowly. I would definitely write down each one of the steps in your screencast notes, and then I would even copy them into your science notebook and just have that with you in class so that you can quickly refer to it than having to jump onto a computer for your screencast notes. Again, review the information, generate a couple questions to share with your teacher in class, and then go and find the atomic structure chart and see if you can fill in some of these Bohr models. And then we also are asking you to draw out the first 20 atoms in Bohr models. Okay? And then here's a short video that you can watch that will walk you through how to write a Bohr model. with some additional information about the periodic table, and that will help you solve some of the practice problems that we have in your unit packet. I'm not going to play this video for you, but this is something that you can play in addition to this one. Thanks for taking the time out to watch this screencast. If you have any questions or comments about how to improve them, please share with your teachers in class, and have a nice day. Bye now.